Hi, everybody. This is Professor Cook. I want to explain to you how to solve this Venn diagram probability problem. This is found in homework 1.2, and you can come across this on question 19. So the Venn diagram shows the cardinality of each set. Cardinality refers to the counted number, so how many items are in the set. And then use this to find the probability of observing the given set, whatever that might be. And you'll notice the question asks us for a probability of A. So a Venn diagram is useful to be able to see the interworkings of different sets of numbers or values, whatever they might be. So we have a circle, the blue circle represents set A, the green circle represents set B, and the red circle represents set C. Now, what's kind of implied here is often in a Venn diagram is that you have the whole, what we call the universe, or the entire group is kind of included like this. So this little 3 out here means something to us. That means the numbers that are in none of those sets. So in this particular world, then you have things in set A, things in set B, things in set C, and then you have the none of these. So 3 represents none. Just so you can see where that comes in, because that could show up in other questions as well. So then the question is, what's the probability of A? So what we need is we need to have the outcomes that are in A. How many outcomes are in A? And then divide that by the total number of outcomes. So just a little bit of information about Venn diagrams and how they're structured here. When they intersect one another, and there's different numbers in the different spaces, that implies how many elements, or that there are elements in the overlap. So for example, this 7 right here represents that there are 7 items that are in both A and B. This 1 right here represents that there's 1 item that's in all 3, A, B, and C. And then you've got 6 items over here that are strictly just in A and C, 9 that are in just B and C. So you've got all these different interworkings going on here. So how are we going to go about solving this problem? What we're going to do is we're going to try to figure out the total number of elements or outcomes that are in A, and the total number all together in the problem. So let's start with A. So looking at the circle called A, you can see that inside that circle, there's a space with 15 elements, 7 elements, 1 element, and 6. So A is going to be equal to 15 plus 7 plus 1 plus 6, which totals, as you can see, to 29 items. So A has 29 outcomes in it. Now, what about the total? Well, the total would be all of the outcomes in the whole diagram. So that's going to include A. So we're going to have our 15 plus 7 plus 1 plus 6. That's A. And we're going to add to it the things we haven't caught from B. So we're going to add also 7 and 9. And then we're going to add the one from C that we haven't caught yet, 9. So every number you see, but don't forget the none. So we need 3 more. So these kind of represent strictly A, I mean, all of the A's, anything that's B but not A, and then anything that's C but not A or B, and then anything that's not in any of the groups. So if you total all that up, you should get 57. And so what that means is the probability of being in set A has 29 outcomes out of 57 outcomes, which divides and rounds to 0.508 something. So it's 0.509, which you can see is the correct answer down here. So I hope this helps you understand not only Venn diagrams, but also calculating probability with Venn diagrams.